In this video, we're going to talk about topic 5.9, example 5. So we have the graph of g prime above. We are supposed to use the graph to determine the intervals of concavity and determine if g has any points of inflection. So I'm going to start with my sign chart. And I notice when I'm talking the second derivative, so I need to look at horizontal tangents. We're going to estimate that the horizontal tangent is at about -1 there. On a test, it would be much clearer than it is in this picture. So our interval looks like it's going from -infinity to -1, -1 to, I'm going to estimate that one at about 2, and then 2 to infinity. Okay, and so we're going to look at what's going on with, I'm going to talk about g prime. I'm going to do it a little differently than I did in the last one, and then g double prime, and then g. So I know that g prime is increasing, which means that g double prime is positive. I know that g prime is decreasing, which means that g double prime is negative. I know that g prime is increasing, which means that g double prime is positive. So if g double prime is positive, it means it's concave up. And if it's negative, it's concave down. All right. So let's put that into, let's talk about concavity. So we know that g is concave up on -infinity to -1 and 2 to infinity because, and remember this is the explanation row, g prime is increasing on these intervals. G is concave down on -1 to 2 because g prime is, again, I got to talk about g prime, is decreasing on this interval. And then as long as my sign changes, I know that I've got a point of inflection. So g has points of inflection at x equals -1 and 2 because g prime changes from increasing to decreasing or decreasing to increasing at these values. Or you could say g double prime changes sign instead of increasing to decreasing.